Alright guys, we are closing in on the end of the chapter, but a couple lessons left to go. So in 4.5 we are getting two more shortcuts for ways of proving that two triangles are congruent to each other. So we covered a couple in the last lesson, and so today you're getting the next two. So we now have angle side angle as well as angle angle side. So here's one thing you really have to start looking at, and this is something I tried to hit on quite a bit in the last video, but the order in which you see these letters do make a difference. So when I look at something like angle side angle, that means I have two angles that are congruent to two angles of another triangle, and the side that we're referring to must be the side that's between these two angles. So let me just draw a basic triangle. Right, so if I wanted to prove that these two triangles are congruent to each other, and let's just say I knew that these angles were congruent, and I knew that these angles were congruent. Right, so if I knew that was true, and I have this side right here, that would be our angle side angle scenario, right? It's got to be the side between the two angles that have been marked. Okay, and so that's super important on this. Angle angle side would be something like this. So if I had more of, and I'm just going to draw one triangle here, but let's just say I knew this angle on some other triangle. So if I had a side like this that was marked, right, this would now be angle angle side, because now I'm not talking about the side between the angles, right? I'm talking about the side not between the angles, right? So that would be an angle angle side scenario. So again, if you're writing your own notes, if you do not have this printed, you do need to write out this angle side angle postulate, as well as write out this proof that we're going to talk through right now. As I'm looking at their given information on this, it looks like they have a bit of a typo on here. So I do not agree with what they wrote here, because if you look at angle CBD, so CBD is not even an angle in this triangle. So their given information was not written correctly. Let me alter that. What they were intending for us to see, let's see, would have been BCA. Is congruent to angle, let's see, so that's BCA, so that's going to be this guy, should match up with this guy. So let's say DAC. So that's what they were intending for us to see. So again, we're going to alter this information right there with the same given information. So this should work out well now. So they're telling us that angle BCA, which is this guy, is congruent to angle DAC, which should have been this one. That would have made much more sense with the rest of the proof that they're trying to put together. So let's go with that. So that's our given information that's already been written within our first couple lines. Of course, we see the parallel lines, top and bottom, and they already marked those for us. But that's super important, and hopefully that stands out to you at this point when we see those parallel lines cut by that transversal that I see. So again, here's the main idea that we're seeing on this, and this takes you back to your chapter 3 drawing, which looked like this. Right? That's the same kind of thing that we're seeing on this. And so if this line is parallel to this line, right, that's going to tell me that this angle is congruent to this angle by alternate interior angles. So that would have been this one and this one. So, and they did write that in here. That's their next line in the proof, is those angles are congruent by alternate interior angles theorem. And again, they did not, ABD, so they did not write those angles correctly, right? So that should have said BAC is congruent to ACD. So it almost looks like the letters they put here, they were intending to draw the diagonal this way, but they didn't draw it that way. So anyway, no big deal. You get the idea. So we're seeing those same alternate interior angles that we've been seeing for so long. We also have this ever so popular reflexive property being thrown back in. BD is congruent to itself because both triangles share that as a side. And so here's the new shortcut that we're getting for proving that triangles are congruent. We have our angle, side, angle. One of the things I want you guys to start looking at on these, now that we have things like side, 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 angle, angle, side, angle, side, angle, side, angle, side, it all gets kind of confusing at this point when you have so many groups of information. So here's one thing I always want you to consider. Whenever you are trying to determine which postulate should get used to try to prove that two triangles are congruent, my best piece of advice is only look at one triangle. So after everything's been said and done, after I've already marked it, I want to just focus on one of the triangles to see what markings have been made. And now I can look at these three marks and see that it fits my angle, side, angle scenario like we talked about right here, right? Because we've marked two angles and we've marked the side between those two angles, so it fits that description right there. So that's really the best way to look at these, is really focus in on just one triangle to determine which postulate is being used. So let's look down and do a couple of our own. Guys, we are not doing paragraph proofs. We are doing two-column proofs. So anytime they say write a paragraph proof, we are not going to do it that way. We are going to do two-column proofs. So if you run into questions within your textbook that say write a paragraph proof, write it as a two-column proof instead. Right? That's what we're doing on these. So these are two very good ones because they're using all of the most common reasons that you guys are going to run into. So these are great examples for us to go through. So let's get through these guys real quick. Again, if you're taking your own notes on your own paper, you do need to write out the full example on these. So let's start with this first one. So we got our given information, S is congruent to V. We want to make sure that we mark that once we've set it within our proof. As well as T is the midpoint of SV. So T, and I'm going to abbreviate here, midpoint of SV, and all that was our given information. So again, guys, whenever you're looking to say, okay, where do I go next in the proof? There's two places that you always look. I always look at my given information that we've already said, and I'm looking to see, is there anything more I can do with this? The other place I'm going to have to look is simply my diagram. Is there anything more I can get just by looking at the diagram? And in this case, we have both things are going to help us. Of course, if T is the midpoint of SV, so here's SV. So if T is the midpoint of that, that tells me that this segment is congruent to this segment by definition of midpoint. Or you could say midpoint theorem. We've talked about that. They both work in this case. The other thing that we're going to see is if I look at the diagram, hopefully you notice our vertical angles that we've been talking about since chapter 1. So hopefully those things are standing out to you. Let's see what we can fill in here. I'm going to start with my given information that said T is the midpoint of SV. So here's SV. If T is the middle of that, that means ST is congruent to VT. And that's, again, you could say definition of midpoint, or you could say midpoint theorem. Both of those tell you that segments are congruent when you have a midpoint. So either one would be accepted in this case. Let's go to our vertical angles. Let's mark what we just said here. So I'm going to mark those. We see our vertical angles right here in the middle. So angle RTS is congruent to angle UTV. By vertical angles theorem. And now look at our diagram. This is how you know when you've come up with enough information. Let's cover up one triangle and just look at that. So if I just look at those markings, I can see that I now have angle, side, angle. And so now I can say this statement has been proven. So triangle RTS is congruent to triangle UTV. And we just saw that that was based on angle, side, angle. And that's it. So not a lot of new information in these proofs other than this guy right here. The other things you're going to be doing are all old stuff, right? So let's take a look at this one. Again, we're not going to do a paragraph proof. You're always going to set these up as a 2-column proof. Let's get that given in there. So a lot of given information here. Let's see. CD bisects AE. I'm going to abbreviate. AB is parallel to CD. And angle E is congruent to angle BCA. So a lot of given information. Let's make sure we mark our diagram with that information before we move on. So we already got the parallel lines marked for us. Nothing we can mark on this yet, but we're going to use that as the next line of our proof. But let's mark this. Angle E is congruent to BCA. So we get those guys right there. All that has been given, so what else can we say? Again, I can go based on my diagram, or I can go based on what we've said already in our given. Let's just start with the given. So if CD, so here's CD. So if this segment is bisecting AE, that means AE is getting cut in half. So that tells me that AC is congruent to CE. By definition of segment bisector. So we've seen two definitions like this. One is definition of angle bisector, one is definition of segment bisector. Of course, in this one, we are bisecting a segment. So we're going to say definition of segment bisector. Let's mark that on our diagram. Now that we've said it, what else can we say? So let's go to our diagram. I've pretty well exhausted the given, except for these parallel lines, but we're going to kind of use the diagram at the same time with those parallel lines. So again, as soon as I see parallel lines, I got to start thinking chapter 3. So here is AB, and it's parallel to DC. And I'm going to draw this line that goes right here. But I'm going to extend those lines so you can hopefully see this a little more clear. So these lines are parallel. So I got AE right here. I got the parallel lines coming through. So what do we see within these triangles? If I look at this angle right here and this one right here, that would be this one and this one, right? Well, in chapter 3 we learned that those are called corresponding angles. And when these lines are parallel, we know that corresponding angles are congruent. So we're going to say angle BAC is congruent to angle DCE by corresponding angles postulate. And so now, if you just look at your drawing, I'm going to cover up one triangle. And you guys can see that we have angle, side angle, postulate. We're just going to say ASA. That tells me those two triangles are congruent. So ABC. And CDE. So that's it. Again, really nothing new within the proof, apart from this one new postulate that's now being thrown into this lesson. Let me keep it moving. So here's the other one that they're introducing to us is angle, side, angle. I'm sorry, angle, angle, side. We just did angle, side, angle. So angle, angle, side is the other one. So again, we have sort of the explanation on that. And as I just mentioned at the beginning of the video, remember the order of these letters, of course, matters. So you saw the way that we drew that out, and we're going to see that within a proof right now. So here is sort of the summary of what we now have. So here are the four postulates well, sorry, I should say 3 postulates and the angle side theorem, because this is actually something you can prove. We're not going to go through all that right now, but you can prove the angle side theorem using other postulates. So, but anyway, what I want you guys to remember is just the 3 letters. All right, that's all we're going to need to put within our proof. That's generally accepted amongst all books when we look at it that way. So anyway, we have the 4 shortcuts. The definition of triangle congruence was what we did at the beginning of this chapter, where we actually had to come up with all 3 angles and all 3 sides to show that 2 triangles were congruent. But as we moved on beyond that, we were then introduced to these 4 shortcuts that we're actually going to be using. Right? We'll never really use definition of triangle congruence to prove 2 triangles are congruent, because we have shortcuts. Right? These 4 shortcuts that you see on this page are what we would be using. So take a look at this example that they have for you. Before I discuss this one, again, guys, just a reminder, if you're writing your own notes, you do need to write all of this down. So you need to put this theorem down. You do need to write the summary statement that you see right here, as well as the example that we're talking through right now. So make sure you get all that written down in your notes. That's how I know that you went through all of this. But this is kind of a great example, because it makes you sort of think, what would my next step need to be? Is kind of what they're trying to get at for this. So if you look at the diagram, you see the given angles that were already marked. Right, so they already marked this right side for congruent angles. So that was given information. And if I just gave you this and I just said, okay, what else am I going to need to come up with in order to use the angle side theorem? Well, as I look at the reflexive line, that's the one that we always use in proofs on these guys, right? So I know somewhere in my proof I would have to say that AC is congruent to itself. So what else would I need to come up with in order to use angle side? Look at angles 1 and 2 for a minute. If I was able to show that angle 1 is congruent to angle 2, would that give us angle side? Again, just focus on one triangle, and we can see that it would not, right? It would give us angle side angle, but that's not what this question is asking for. This one is saying, what would you need in order to use AAS, right? And so that means, oh, I would need angle B and angle D in order to use angle side, right? And so this is kind of a great question, because it's making you think, if I was going to do a proof, what would I need to come up with in order to make this work? Okay, so there's a great example of what would be needed. Plus, I just like the way that it's starting to help you see the difference between those 2 ideas right there, right, in the order in which those letters are being shown to us. So let's go through one more proof together. Again, guys, taking your own notes, just go ahead and write this one out. Write down the information. Make sure you draw the diagram. That's all so important in doing these proofs. So let's just start with us given information. So we got parallel lines. Hopefully that super stands out to you at this point. BC is parallel to EF. And AB is congruent to DE. Which we definitely want to mark in our diagram. And angle C is congruent to angle F, which we also want to mark in our diagram. They already marked the parallel lines for us, so all of that was given information, so this should be nice and simple. Alright, so as always, let's take a look at our given information. Is there anything more I can pull out of this? Not a ton, other than I do know that I have parallel lines, so let's use this and say, okay, that's going to point me to the diagram, right? Let's look at our parallel lines and see what else I can get out of this. So I have this line is parallel to this line. Here is my transversal that cuts both of those. So if that's the case, what more could we say? Well, this angle, which is this guy, must be congruent to this angle, which is this guy. And again, just like we saw from our last proof, we know those are corresponding angles. So we can now say that angle, I can't just call this angle B because I wouldn't know if I'm referring to this one or this one. So we really should use 3 letters on this one. So let's say angle ABC is congruent to angle DEF. And that was the corresponding angles postulate. So, anything else we need to say? Let me just look at one triangle here, and let's focus on the marks that we have. I have angle, angle, side. And again, guys, we know it's not ASA because I did not use the side between the angles. I used the side that was next to the angles, right? So I got to see this as angle, angle, side. So we're just going to put that given information, the prove information that ABC is now congruent to triangle DEF by that reason right there. So that is it for this one. Obviously a lot of proofs going on within this lesson, so want to make sure that we're drawing back on those old reasons that we've been learning throughout the year. So that's the end of that section.